Good morning to all. So today I would like to cover some of the basic concepts regarding digital logic circuits. Okay. So first of all, we are going to discuss about the number systems. There are four types of number systems. Okay. First one, decimal. This is the standard number system. Second one, binary. Third one, octal. And fourth one, hexadecimal. Okay. First, we will discuss about the decimal number system. Okay. So every number system is having a base or radix. Base or radix. If a base or radix of a particular number system is R, then the different symbols you can represent in that number system will be 0 to R minus 1. 0 to R minus 1. So if you take decimal number system, the symbols you can represent in the decimal number system will be 0 to 9. Why? Because the radix of the decimal number system is 10. So if you take binary number system, the radix of the binary number system is 2. So that is why we can represent two different symbols. Okay, the symbols in the binary number system are either 0 or 1. So if you take octal number system, the possible numbers you can represent in the octal number system, the possible symbols you can represent in the octal number system are 0 to 7. If you take hexadecimal, so the name indicates itself hexadecimal. Decimal means 10, hex means 6. So 10 plus 6, 16. So you can represent 16 symbol. So that means up to 0 to 9, decimal numbers and hexadecimal numbers are same. So 10 can be represented by A, 11 can be represented by B, 12 can be represented by C, 13 can be represented by D, and 14 can be represented by E, and 15 can be represented by F. Okay, so these are the four number systems. Okay, out of these, the standard number system is, you know very well, decimal number system is the standard, and most of the cases we are going to prefer the hexadecimal number system. Okay. I think you get the point regarding, so what are the different types of number systems very well. Now let us see the process of conversion of a number in one base or one radix to the number in another base. Okay, now we will start with the standard procedure, conversion. Suppose I want to convert a number in decimal to a number in binary. I will tell you one common procedure. Okay, that is, if you want to convert any number system to binary. So decimal, you are converting decimal number into its equivalent binary number. So the process is simply division. The process is simply division. Okay, let us take one example. Suppose if 51 is the number in decimal, so what is its equivalent in binary? Okay, now simply the process is nothing but division. So that means division is nothing but you have to divide the decimal number with the radix 2. Okay, so that means divide 51 with 2. How many times it will go? 25 times. So every time write the remainder. Next again 12 times 1. Again 6, 0. Next again 2, 3, 0. Next again 2, 1, 1. So you have to repeat the process until uh, this number should be less than 2. Okay, now we need to stop the process and you have to write the reminders from bottom to top. So including the quotient. Okay, now so 1, 1, 0, 0, 1, 1. So what is the corresponding equivalent number? 1, 0, 0, 1, 1 in. I think you understand. You understood this concept. Now I'll tell you the next process, that is binary to decimal. Suppose if a number is given in binary, then what is its equivalent number in decimal? Okay. So if you are converting decimal to binary, then you are following the process division. So exactly vice versa. If you want to convert the number from binary to decimal, then the process is multiplication. Multiplication. Okay. Now we'll take one more example. Suppose take the same number and convert the following number in binary to its equivalent in decimal. Okay. Now take the same number here. 10011. Now I am asking you to convert the number 10011 in binary into its equivalent in decimal. So what should I tell you previously? The process is multiplication. Now this is called LSB. The rightmost bit is the LSB and the leftmost bit is the MSB. Okay. So write the numbers 10011. I am telling you the simple procedure. Okay. Triple one, I think. Okay, whatever it may be the number. Okay. Now start with the LSB. The weight of the LSB is 2 power 0. The weight of the next bit is 2 power 1. Next bit is 2 square. Next bit is 2 cube. And next bit is 2 power 4. Like that. Suppose if there is one more 1 here, then the corresponding weight is 2 power 5. Okay. Now, but my intention is to convert 10011 into its equivalent decimal number. So that is why only you have to take the weights corresponding to the bit 1. Why? Because here if you want to multiply 2 power 0 with 1, then you will get the number. If you want to multiply 2 power 1 with 1, you'll get the number. But if you multiply 0 into something, it will be 0. So that is why don't consider the weights corresponding to bit zeros. Only consider the weights corresponding to bit 1. Okay. So there are 3 ones here. So the corresponding weights are 2 power 4, 2 power 1 and 2 power 0. Add those weights. 2 power 4 plus 2 power 1 plus 2 power 0. So what is 2 power 4? 16 plus 2 plus 2 power 0, 1, which is 19. Okay. I'll tell you the one more method to conversion. Okay. Not this one. So we'll take binary to octal conversion. Next conversion is So I'll divide the board into two parts so that it will be clear to you. So binary to octal. So simple method to convert the binary number into its equivalent octal number. So what is the radix of the octal number system? 8. And what is the radix of the binary number system? 2. What is the relationship between 8 and 2? 8 equal to 2 cube. So that means to represent one octal in binary, you require how many bits? 3 bits. So I'm writing the octal numbers and the corresponding binary numbers. This table will require, okay, so first 0, 0, 0, 0, 1, 0, 0, 1, 2, 0, 1, 0, 3, 0, 1, 1, 4, 1, 0, 0, 5, 1, 0, 1, 6, 1, 1, 0, and 7, 1, 1, 1. Now, binary to octal. Some binary number is given. Now, they're asking you to convert its equivalent octal number. Now, here you are going to know this table first of all, and then there are two parts here. One is the integral part, and second one is the integer part and the fractional part. Okay, now. So first take the integer part, that is 101101. Okay. So from right to left, okay, you are going to divide the data into groups such that each group contains 3 bits. Okay. So here already 3 bits are there. Suppose if one more bit is there, suppose if one more 1 is there. So 3 and 3 are there. 1 bit is left over here. So for that, you can add 2 zeros on the left side. Here exactly I have taken 6 bits, so that's why no problem. 3 plus 3. But if 7 bits are there, then 2 into 3, 6 bits. 2 groups plus 1 bit is left over. If that bit is 1, okay, on the left hand side, you can add 2 zeros. You can add 2 zeros. So then you'll get 3 bits. Okay. Suppose if the leftover bit is 0, then there is no need to add, because if you add 2 zeros towards left side, then it will 0, 0, 0. If you convert 0, 0, 0, then definitely it will become what? 0. Nothing of importance. Okay. So that is why 101, 101. What is the 101 equivalent number in octal? 5. So similarly, 101 here is there, 5. And take the fractional part, 10110. For the integer part, you are grouping the bits from right to left, such that each group contains 3 bits. For the fractional part, exactly you will follow the reverse order. So that means group the bits from left to right. There, if one bit is required, then you can add 1 0 towards left side. Here, you can add 1 0 towards right side. Simple. So what is 101? Again 5. And what is 100? 4. Okay. Now this is the fractional part and this is the integer part. Now the answer is 55.54 is the equivalent number in octal. Next, octal to binary. Octal to binary, what is the conversion? The binary to octal, simple. Group the each, so that means if there is a string of ones and zeros, or there is a group of ones and zeros, divide the entire data into groups such that each group contains 3 bits. On the integer part, on the fractional part, same procedure, but the direction. Integer part will be from right to left, fractional part will be from left to right. Okay. So exactly the reverse process, octal to binary. Suppose if you want to convert the octal number into its equivalent binary number, then the procedure is you have to follow this table. Simple. So represent every octal digit by 3 bits. So what is the octal equivalent? What is the binary equivalent of 5? 101. Again 101 dot, again 5. 101. Again 4. 100. I think you get clear understanding about the conversion from binary to octal and octal to binary. Next one, binary to hexadecimal and hexadecimal to binary. Binary to hexadecimal. Same like mm, what is the radix of the hexadecimal number system? 16. So what is the radix of the binary number system? 4. What is the relationship between 16 and, sorry, 2? That is 16 equal to 2 power 4. So that means to represent one hexadecimal number, okay, in binary, you require 4 bits. Okay. So there is a table here. I'm going to show. So up to 0 to 9, decimal numbers and hexadecimal numbers are same. You have to follow this table. After that, 10 is represented as 1010. So 10 is nothing but A. B, which is 1011. C, 1100. D, 1101. E, 1110. And F, all ones. Okay. Like the previous table, which you follow for the conversion from binary to octal and octal to binary, like that, you can follow this table from binary to hexadecimal and hexadecimal to binary. Okay. Now we'll take one example. Okay. How to convert a binary number into its equivalent hexadecimal and vice versa also. Now you have to group now 4 bits because to represent one hexadecimal number in binary, we require 4 bits. Suppose if I take a binary number 1011, 1101, 11 in binary into its equivalent hexadecimal number. Okay. Now group the bits from right to left such that each group contains how many bits? 4 bits. Now again 2 bits left over here. You can add 2 zeros. Now what is the corresponding 0 triple 1? 7. Okay. I'll tell you very clearly. A 1010, B 1011, C 1100, D 1101, E 1110, and F all ones. F next 0010. Now this is the equivalent number in hexadecimal. Like that, if you want to convert hexadecimal number into its equivalent binary number, then the procedure again same for the whatever may be the procedure that you follow for the octal to binary conversion, then represent every hexadecimal digit by the corresponding 4 bits. Suppose if 597 is given, 5 is represented as 0101, 9 is represented as 1001, and 7 can be represented as 0111, like that. Okay. Okay. Now the next procedure is Erasing. One minute. There's a problem with the board. Okay. Okay. Now this is eraser is not working. Okay. We'll take another new whiteboard. Okay. Next. Next one. Mm. Decimal to any. I already told you. Decimal to any. What is the procedure? Division. So that means if you want to convert decimal number into its equivalent octal number, then you have to divide the decimal number with octal. What is the radix of the octal number system? 8. So if you want to convert decimal to hexadecimal, then what is the procedure? Divide the decimal number by the corresponding radix 16. So if you want to convert decimal to binary, then you have to divide the decimal number with the radix 2. Next procedure, any to decimal. Any to decimal. Okay. So that means binary to decimal or octal to decimal or hexadecimal to decimal. Then what is the procedure? The simple procedure is the multiplication. I'll tell you one example so that I can conclude the video. Suppose an octal number is there, 72 in octal. It's equal to how much? It's equivalent in binary. What is the procedure? Any to decimal. Okay. Any to decimal is nothing but multiplication. So that means write the number digit 2 and the corresponding weight will be 8 power 0 plus 7 into 8 power 1. So this is 56 plus which is 2, which is 58. Suppose one hexadecimal number is given 2F7 in hexadecimal is equal to what is its equivalent in decimal. Then follow the same procedure like this. It is 7 into 16 power 0 because the radix of the hexadecimal number system is 16. Suppose if you get alphabet here, okay, whenever you encounter alphabet, then you know very well, A is represented as 1010, B is represented as 1011, C is represented as 1010. Sorry, I want to say A 10, B 11, C 12, D 13, E 14, and F 15. So here you got F. F is nothing but what? 15. F is 15 into 16 power 1 plus 2 into 16 square. Simplify this one and you'll get the corresponding number in hexadecimal. So decimal to any conversion, division, you know very well. Okay. So this is about the conversion of number systems. And one more I am missing, that is octal to hexadecimal and hexadecimal to octal. So this is the simple. So if you want to convert octal to hexadecimal, I'll tell you this best procedure. First, convert the octal number into its equivalent binary number and then convert the binary number into its equivalent hexadecimal number. This is the best procedure. Similarly, for hexadecimal to octal, first convert the hexadecimal number into its equivalent binary number by using the table, and thereafter convert the binary number into its equivalent octal number. So that's all the information I would like to present. Hope I presented successfully. So thank you for watching my video.